Hi, this is Gleb Bakhmatov. We have a visual canvas test. It compares the animation step by step, which means we are manually advancing the frozen clock from nothing to 150 milliseconds before comparing the rendering to a previously saved image. When we advance it again by 300 milliseconds and compare it to previously saved image, when we advance the clock to 450 milliseconds, taking a snapshot, and then 400, and this is the final image that our canvas is rendered. And all four images match. But our task has a lot of repetition. Look at this. Tick 150, take the image, compare it several times until it matches the canvas. Tick to 300 milliseconds, compare, and so on. So in this video, I'll refactor it to be simpler. Here's how I will do it. First of all, let's talk about this value, 150 then 300. Let's have a variable. We'll say let tick equals 0. And we're going to advance this variable by 150 milliseconds. So we're not going to keep the track of this code. Now, every time we want to advance it, we'll have probably to pass it to this code so that we pick the right file name to compare it to. So why don't we have a function, a utility function that will keep track of this variable, and it will even yield us the tick value so we can just create a file name automatically. So I will call it control clock. So it's a little function that we will call first, and I'll call it, let's say, tick tock. So clock. So here's what we will do, right? Every time you say I want to control the clock, we're going to freeze the clock automatically. And then I'll return another function where you will pass the value of a clock you want to set. And because we always advance by 150 milliseconds, I'll just give it default value. Here's the tricky part. Here's how we're going to use it. So we're going to say, let's say, talk, which advances the clock by 150 milliseconds, and then we want to call the recurse, right? And that's where we want to say the current tick or clock value. And we want to put this thing right inside this function. And we're going to tick, and we're going to use it. So it will give us 150, 300, and so on. So we really want to put it right here in our file name and milliseconds. And I'm just going to delete this for now because we'll duplicate the code above. So right here, if you want to attach something to the value returned from this function, we'll have to return sci.then, and then we'll give a callback. So every time you call talk, right, what do we want to do? We want to put it inside the then, so it gets scheduled into the command chain, right? Then we want to say tick plus equals milliseconds. So we're going to advance the local variable, call sci.tick, the tick, okay? And then we're going to return the current value of the clock, right, by saying sci.wrap. So this is what yields every time you call it. You literally calling then, and which is yields the value of a tick you pass right here. So let's see if this works. Perfect. So it does work. So we no longer have to keep track of the clock variable, and we can just duplicate this. Advance by an hour, and an hour, and an hour. So this will create 150 millisecond, 300 millisecond, 450, and 600 millisecond image. And notice this is correct. 450, 600. Perfect. And here's the cool part about this refactoring. Now, look at this. Yes, we duplicated, but we never had any local variables. We never had to do anything different in each block. We didn't even have to have a counter. Everything is done inside this function. Every time you call it, it advances local variable. Well, you literally call this function. You advance the tick, you call sci.tick, then you wrap the value, and it's all part of Cypress chain of commands. So what we can do is remove everything right here and instead say for let k equals 0. Okay, let's say 4. We're literally using normal iteration, and this will call this command 4 times that all get queued up in Cypress command chain and then execute one by one. So let's look at this. Perfect. Executes exactly the same way as our duplicate code. So by removing all local variables, by putting them inside the side then commands, right? By removing all global state, just having local state everywhere, we've been able to use a for loop, which normally you don't use. But in this case, you just use for loop to schedule all 4 blocks of Cypress commands. And then you can do visual comparison at every timestamp.